The next module is application layer. Again, this is something we have covered in the lecture in detail, but we're going to touch it as part of your CCNA-1 as well. So we will look at application layer and explain all of the operation and all of the application layer protocols that we need to know in order to do our work, and what protocols give support to our applications. Okay, so let's have a look at it. Usually, we used to have the application layer consisting of application, presentation, and session, okay, in the early days, whereby from transport layer, it goes to session, then to presentation, then to application. But now that application layer itself takes care of the functions of presentation and session layer. If you look at your TCP/IP model and your OSI model, your TCP/IP model, your application layer, actually takes care of both application, presentation, and session. Even in OSI model, your application layer actually has got your protocols and functions which do the work of presentation and session. What I'm trying to say is there is no clear-cut divide anymore, okay? Some of the protocols that actually work on your application layer, well-known protocols are your HTTP, FTP, TFTP, IMAP, and DNS. So we'll be having, we'll be looking at this and learning some of the commands actually to help us understand these application layer and their protocols. If you have to divide it per se, your presentation layer is responsible for formatting and presenting data, okay, at the source device. Compression, again, presentation layer. Encryption, again, presentation layer. Your session layer, it creates and maintains dialogues between source and destination, and it handles the exchange of information. Okay, like I said, all the functions of presentation and session can be handled by just your application layer. Okay. So some of the protocols that we have in your application layer, okay, is your DNS working on both TCP and UDP on port 53, your DHCP on port 67 and 68, again using UDP, your HTTP on port 80 or 8080. Okay, so these are some of the protocols and their ports, famous protocols and their ports. Now, when we try to establish a connection in application layer, there are two kinds. There can be client-server model. We have studied this again in the lecture, and peer-to-peer model. In a client-server model, you have got a computer, usually more powerful, more having more resources, and another device, okay, accessing this server and using its resources. Okay, this is a client-server model. In a peer-to-peer model, there is no clear-cut server and client per se. Any peer can act as a server. For example, if you attach a printer to a computer, okay, so this can act as a print server, okay, and so on. So in situations like that, in peer-to-peer network, there is no clear-cut role, which is the server, which is the client. Both the peer can access each other's data, and both can be a server for one application and client for the other. Okay, so the roles is not clear cut. It's depending on the request sent. If you're using a peer-to-peer application, okay, again, you can have a client and a server, and these roles can be changed. Okay. So some of the peer-to-peer requests, some of the applications that we have are given, and the most famous of these is our BitTorrent for downloading files and trying to get access to videos, data, music. Okay, this is one of the results of your peer-to-peer applications. As I told you in the lecture, this was actually famous in the early 90s when the music industry was under strain because of Napster. They came up with this application that could exchange music files. And once they knew the whole process of Napster, how it works, then they started not only limiting themselves to music files, but also data files, video files, and so on. Okay. A few years ago, there was this guy who uploaded the details of printing a handgun, a plastic handgun, and you could download it by using BitTorrent. And if you have a 3D printer, you could print your own gun. Okay, so on the surface it may look innocent, but then it can be dangerous as well. Okay. The concept of intellectual property, the Hollywood studios, okay, running into millions and billions of losses because the movies are, not purchased by using Blu-ray or DVD or CDs. Instead, you can just download a pirated version and watch it. Okay, so that's still stealing, information stealing for your information. But then these are some issues that people don't want to talk about, don't want to raise it up. But the person who has created the intellectual property, that one is an issue because the hard work and the labor is not being paid for. Okay, and then that won't be a motivation for them to do it again. Okay, so that's an issue that we need to consider. Okay, some of the web and email protocols that we are used to is our browsing, which is enabled by our HTTP. Okay, usually the first step is a client using a browser, which is a client application, will type a URL, a uniform resource locator, which is an address consisting of what protocol you are using, which server you want to go to. Okay. Remember, again, your routers will not know this. They will only know the IP address. So you have to have a DNS translation. And then if you're going to this server, what is the file name that you want to access? So once you give that information in your browser's URL section, then it will send a request. Okay. So first it will send a request to a name server. Okay. That name server will first try and find out what is the thing that which website you're trying to connect to. So if you're trying to connect to www.cisco.com, it will get the IP address of that www.cisco.com. Once it gets the IP address, then it will get the HTTP will give the GET request to get the index.html file. Okay, HTML is the standard for your web pages. That is your hypertext markup language, a very simple language to learn. You can create a simple web page. Okay, and it will send it to the actual server. Now you have translated, remember, to IP address. So it will forward it to your server. Once it forwards to the server, the request will be sent by the server, okay, in the form of HTML code. All that the server does is it sends HTML code to the requesting client. Next, the requesting client has got a browser. Let's say I'm using Chrome. My browser will translate that HTML code and will show me the web page I can see. Okay, so these are the 4 steps whereby your HTTP works. We also have a HTTPS, okay, which is a secure version of your HTTP, because HTTP is not secure. But when you have used HTTPS, then it is secure. Okay. If there is a packet sniffer, they can get your data and know what you are trying to, what pages you are looking for. Your HTTP has got 3 messages, types of messages. One is GET. GET is a request from a client. POST, if you are filling up a form, you want to send the data from the form to a server, then it will send the POST. And PUT is for uploading data like a picture or a video to a server. With regards to email, there are certain protocols that you have to know, and some you have studied already in the lecture. That is SMTP, which is used to push your email from your device to the relevant server. And you have POP protocol and IMAP protocol, which are responsible to get your email from the server to your device. Okay. When you're sending an email, your SMTP will take your email, okay? Your SMTP protocol will take your email and send it to the SMTP server. It will look for the email address. If it's not in this server, then it will again push it by using SMTP to a relevant server. Okay, and SMTP is on port 25. The moment you see port 25, you know that it's associated with your SMTP server. Okay. Just as SMTP is responsible for pushing your email, sending your email from the client to the server, okay, similarly, your POP3 is responsible for getting from the server, okay, from the server, bringing your email to the client, to the recipient. Okay. Now, the thing is, when POP3 does this, when it sends from the server to the client, it empties out, okay? It empties out the whole storage of emails, and everything is on your computer. If something is wrong with your computer or your device, then you cannot get it again from the server. It's not centralized. So perhaps a better option than POP3 would be your IMAP. In IMAP, it will just send a copy of everything to your device. If you physically delete it from here, it will synchronize and physically delete over here. So the good aspect of IMAP is whatever is on the server will be replicated on your device. If you have got multiple devices, 1, 2, 3, 4, 5, it will replicate to all the 5 devices. Okay? And if you delete in one, it will immediately synchronize and delete from the server, and that will be reflected on all the recipients. Because this is the age where we are not satisfied with one device. We have got multiple devices, right? Look around you. How many devices do you have? I'm sure it's not one. You've got your smartphone, you've got your PC, you have got perhaps other devices, okay? And throw in some IoT devices in the mix, so it gets more complicated. That's why, rather than POP, IMAP is a better option. Let's move on to IP addressing services. The best one is your domain name service, okay, whereby your fully qualified domain names like http www.cisco.com, okay, are easily rememberable. What kind of word is that? Rememberable. Is there such a word? I'm not so sure. Can be easily remembered rather than the IP address 198.133.219.25. Okay, it will be very difficult to remember that. But then, if you have got your domain naming system server, it can translate, okay, your FQDNS names to IP addresses. Okay. So when you type www.cisco.com, it goes to a name server. It will translate your cisco.com to a relevant IP version 4 or IP version 6 address, and then send a request to the server. Once it sends a request to the server, you will get the information. Okay. Your domain naming server has got certain record types. If you get A, that means the end device has got IP version 4 address. If you get quad A, that means IP version 6 address. If it is NS, that means authoritative name server. And if it is a mail exchange server, that means it will have MX. Okay, so these are some of the record types associated with your DNS server. And also, the DNS message will have a certain section which can be a question where you are asking what is the relevant IP version for this name. That can have an answer, can have an authority or additional information. Okay. Usually, DNS is hierarchical. Okay. So you'll have a root level domain, and based on that, there will be a top level domain. So in this world, you already know that we have got .net, .edu, .com, and every country has got its own domain name associated with it, .co and so on. Okay. For example, under .com, we have got our Cisco.com. Okay. Curtin would be under edu. Okay. Cisco, perhaps your NetAcad may be under your net, and so on. Okay. Before we go to NS lookup, let's do. Okay. So what I am doing here. I want to make my font big so that, yeah, all of you can see it better. So 28 is a better size, right? Isn't this better? Yeah. So keeping that in mind, what I'm going to do is, this is, I think, one of your labs. I'm going to, let's say, ping your, your internet corporation for assigned names and numbers. I can. So I'm going to ping your www.ican.org. Okay. Now, when I ping it, if you observe, I'm getting immediately, you see, I'm getting IP version 6 address. Can you see this? It shows me IP version 6 address. Now, the thing is, let's say I want to translate this into an IP version 4 address. So what I do is, if I'm not mistaken, yeah, I type version 4. Yes. Now I get my IP version for relevant address with regards to my www.ican.org. Okay. So what I'm going to do is, you see, let's just copy and paste this. Okay. Just in case, let's go and copy and paste this as well. Okay. Now that I have these IP addresses, I'm going to open my browser. Yeah, let's go to my browser. Open a new browser. Okay. And using HTTP, what I'm going to do is, yeah, let's try this. Okay. Let's say we are living in a world without DNS. There's no such thing as DNS. Then this is how we'll serve. Okay. We'll surf the net. Yes, it connects me to ICANN. As you can see over here, that's how it works. Okay. So you can see that the benefit of having our domain name server. Otherwise, things would be very tedious. Okay. Let's try the other one as well. Again, another browser. What's the other one? Yeah. Copy and paste. This is IP version 6, right? So HTTPS. This time we use S. Okay, // there. Do I put the brackets? Let's just try. Yes, it works. Okay. So both IP version 4 and IP version 6, you see, you can actually serve by using the IP addresses. It's a naming system server that translates it into a relevant IP address. Okay. So we also we also have an NS lookup command which gives us information about which is our domain name server, okay, our DNS server name. Okay, so that is also something that you can try and find out. For example, in your case, your internet service provider, who is your DNS server service provider? Okay, so you can run that by using your NS lookup. Let's just try. Okay. For example, NS lookup. There. My domain name server naming service is cdns01 version 6.tm.net.my. Okay. And that is the IP version 6 address. Okay. So you can get information like that. What else? What other commands I can give over here? Let's say, give me information about Cisco.com. I think this is in your lab as well. Okay, there. It tells me that is the access name. These are the IP version 6 addresses, IP version 4 address, and these are the aliases, the DNS aliases for www.cisco.com. Okay, there we go. So you get details like this. When you study your cybersecurity, you will actually study how these websites you can check, okay, for vulnerabilities. You can check on how you can find loopholes and how you can hack, okay? So that is also very interesting, actually. You can also do a specific, by using a specific lookup, you can say like, let's say, find the mail server. Yes, let's say set type. You see, if you remember, see, when we study, our DNS, MX is related to your mail exchange, correct? So let's say I say set type is equal to MX in www.cisco.com. There, it will tell me what are the mail servers, okay? Primary name server, and yes, okay. Does it have the MX? Well, let's try again. Exit. It should get the I should get the MX field. Okay, let's try again. So what I do is ns lookup. Okay, now set type sorry, equals MX, because I'm trying to access information relating to the mail exchange server, and I type www. No, let's try cisco.com. cisco.com. Yes, there. It tells me my mail exchange server. Okay, there. You get information about that mail exchange server. On the surface, it may look innocent, but you can actually get more information by using your NS lookup. You can do a lot of things over here, actually. Okay. Yeah, that would be beyond the scope of this. So let's move on to, remember we are doing CCNA1, okay? So this is your NS lookup, which gives you more information about your DNS. We also have a dynamic host configuration protocol whereby our DHCP device can automatically give IP addresses to our devices, okay? Over here, we can have a DHCP server configured on a router, and this router will automatically generate IP addresses to our devices. Like I said before, this is something you're going to do in your CCNA2. Usually, a client will send a DHCP discover request, and the DHCP server, which may be a computer or a router, will generate a DHCP offer, and based on that, it will request, and then it will give a DHCP acknowledgement, okay? And once you get that, you will get your DHCP IP address. If for some reason the IP address is not available anymore, then you can generate a DHCP negative acknowledgement, okay, to remove that IP address. We also have in the application layer your FTP protocol, which allows you from a client to establish a control connection on port 21. When you create a control connection, that means first you establish a control flag on port 21. And once that connection has been established on port 20, then you can start exchanging data. Data can be pulled or pushed. You can pull a file from the server, or you can upload or push a file from your client to the server. Okay. Now, when you establish a FTP connection, the issue is every time you have to establish a connection, a control, port 21. A better option is something known as SMB, which is a server message block. It will leave the connection open. It will start, it will authenticate based on a proper account, okay? And then the connection is open. And then you can exchange data. What is the benefit of SMB compared to your FTP? SMB will establish a long connection, okay, rather than a short connection. Let's say you're streaming, okay, and you need a long connection, or if you are engaging in video conferencing and so on like that, okay. So that brings us to the end of our application layer, topic number 15 as well. Anyone has any questions with regards to this? If you have time, please look at the lab exercises related to this. Okay, there is one for lab for chapter 14. There are no lab exercises. For chapter 15, there is one lab exercise which you can actually try out by running the DNS NS lookup command, and also trying to run your some of the commands like I told you. Okay, your DNS command, your NS lookup command, and so on. Your ping command, where you ping your either you can ping your Cisco or some websites that you know. Okay. So that brings us to the end of the session.